If you joined us for our 101 webinar, where we covered an overview of our Total Boiler Room Solutions product, you remember that it consisted of three main components: the touchscreen at the boiler, we also had a DA panel, and then the master panel. And today's webinar is going to be all about the master panel itself. We're going to dive into the different features and functions, and there's so much this master panel really can do that we're not going to be able to cover everything in detail today, but we are going to dive into some of the more basic functionalities and show how they can be set up on the master panel itself. So if we take a look at a feature summary, the first thing you want to really note is that the master panel is a multiple boiler control system. So you're going to be hooking up multiple boilers to the master panel, and it's going to be controlling the firing rates of those boilers in order to achieve a system set point. The master panel can be ordered as either a steam or a hydronic panel, and it can be configured for both. You can lead lag up to 8 total boilers using the master panel, and it will do auto boiler rotation, which means it'll rotate which boiler is the lead boiler and which boilers are the lag boilers. You can connect an LMV, local touchscreen kits, or RW55 to the master panel. And if you joined us for our 101 presentation, we kind of went over that, and we'll review this in further slides. You can use the master panel to monitor a DA, surge, or condensate panel. So that's one of the other panels we have in this portfolio. The master panel doesn't need to be in the boiler room. It actually can be in a totally separate control room as long as it's connected to the same network. The master panel comes with 4 analog and/or 4 RTD inputs. So in a steam system, the master panel automatically has 4 analog inputs. And in a hydronic master panel, you automatically have 4 RTD inputs, but the other card can be optioned in. The master panel can have BMS communication protocols in there, so you can communicate via BACnet or Profinet or LawnWorks or any of the various BMS protocols that are out there in the boiler industry. And the graphics on the master panel are adjustable, so that you can make the master panel look just like the boiler room that your customer has in front of them. The master panel can also be set up with email or text messages. And this gives the ability for the master panel to send out notifications when there's an alarm, or even to send out a full alarm history or screenshots manually when you're trying to troubleshoot something. The master panel has the ability to do dual set points and remote set points. It also has some very advanced PID controls. So not just your standard PID values, but also some additional controls that help maintain the firing rates of certain boilers in certain situations in order to create a better system control. The master panel does low fire hold. Some people know this as cold start or thermal shock protection, but it's part of the standard software inside of the master panel. The master panel can also handle warm standby, which is different from low fire hold, and we'll dive into that in later slides. It can also handle outside air temperature reset schedules, and this would be for a hydronic system specifically. The master panel can also handle boiler circulation pumps and isolation valves. It can also control system pumps, so it can control primary loop system pumps from the master panel, and there's various setups that you can go really deep on. We're actually not going to cover this in detail today. It's a more advanced setup, but we'll maybe cover it in a later webinar. Master panel also has a full scheduling system that allows you to turn on or off the system at different times of the day. You can also do data logging and trending right there in the master panel, so you can see a trend of any Modbus point right there on the screen. The master panel can also be remote viewed. So using the ACS 800 software, you can actually view the master panel or other touchscreen products from a PC that's connected to the same local network. The master panel also has an alarm history that stores up to 250 alarms, but it's not only for the system alarms, it also stores alarms from each individual boiler that's connected to the master panel. Master panel also has something that's called user values. Now, these user values are basically calculations that can be created using any of the Modbus information that we have from the master panel, the analog inputs, the various boilers. And what you can actually do is show things like a real-time fuel to steam calculation right there on the screen. It's extremely powerful, but again, it's one of those more advanced features that we may not have time today to go through in detail. All the information today that I'm presenting is covered in detail in our master panel installation instructions. And as a matter of fact, you can download it right now from that handout section of the GoToWebinar dashboard. This documentation and all of our documentation on the Total Boiler Room Solutions product lines is available on our website at scccombustion.com. If you need help with any of this documentation or you need more information on this kind of thing, feel free to reach out to your SCC account manager, and they'll be happy to answer any questions that you have or dive deeper on certain subjects with you outside of this webinar. So let's review how we connect to the master panel. Now, this will look familiar to some of you that attended our 101 webinar. So let's say we have a master panel here. We also have a DA with a SCC DA panel. Now, if you have a DA panel, you're going to connect that to the master panel via an Ethernet connection. Let's say you had a new burner that had an LMV on it, and it also has a Siemens touchscreen kit connected to the LMV. That touchscreen kit you'll connect directly to the master panel using an Ethernet connection similar to the DA panel. Maybe you also have a retrofit in a box or one of our combustion enclosures. Because that has a touchscreen as well, you're also to connect via Ethernet in this case. Now let's say you have an LMV5 without a touchscreen, or you have an LMV3 without a touchscreen. Both of those can be connected to the master panel, but first we're going to install serial comm kits. These serial communication kits can then be daisy chained together back to the master panel. And this is a serial connection. So it's different from the Ethernet connection. And this is going to be important later on when we get into some of the setup screens. Now, if you have a burner that doesn't have an LMV on it and you want to connect to the master panel, that's no problem. All we're going to need to do is add an RWF55 as the load controller for that burner. And now you can tie that into the daisy chain and make a serial connection back to the master panel. So again, that would be a serial connection. And then last but not least, don't forget to connect the header sensor. Whether it's a hydronic system or a steam system, you need either a header pressure sensor or a header temperature sensor or loop supply sensor back to the master panel in order for the system to work. If it's not there, the system will say it's unavailable and it will not work. Once you have all of these things connected, you can also connect the master panel to the BMS via whatever protocol they require. So that's a quick summary there, how we connect everything up to the master panel. And we're going to reference this page a couple of times throughout the presentation to discuss how we set up the master panel. So let's run through a basic sequence of operations for the master panel itself and how it controls the boilers in a system way. So in this example, we have 3 different boilers, all connected to the same header, and it's a steam system, okay? So we've got a master panel connected with our header pressure sensor. And the first thing that's going to happen is the master panel is going to compare the process variable, which is the header pressure, which you see here at 90 PSI, to the system set point, okay? That's the set point inside of the master panel. Now, it's important to remember that there's a difference between the system set point, which is at 100 PSI, and then the local set points. So now we have local set points here for, let's say, boiler number 1 is 100 PSI, and actually boiler 2 and boiler 3 all set for 100 PSI. But these are different. These are local set points compared to the system set point, which is at the master panel. The header pressure here is called the process variable. But again, this is the system process variable, and there are different process variables for each individual boiler. And these are going to be the pressures at the boiler themselves. So at boiler 1, we have a 90 PSI pressure, which is the process variable for boiler 1. But for boiler 2, we only have a 70 PSI process variable. Okay, so it's important to understand the difference between the two. There's a system or a header pressure sensor and a header pressure, and then there's a individual boiler process variable or boiler pressure, okay? So the first thing the master panel is going to do is compare the header pressure to the set point and determine if you're at set point or below set point. Once the master panel has done that, it's going to use its PID settings to generate a demand percentage. Now, demand is determined by how many boilers you have, or the total demand, I should say, is determined by how many boilers you have. So in this instance, because we have 3 boilers, we can have a total of 300% demand. And that means it's an additive number. So if you wanted to have 2 boilers at 100% firing rate, you would have a demand of 200%. So once the master panel has generated this demand number, if the demand number is greater than 0, the lead boiler is started and fired at the PID demand rate. So we'll see here that boiler 1 was turned on. It's now running. You can see it in the green bar there. And then it's running at a rate of 80%. If the demand percentage exceeds the lag start percentage for the duration of the lag start delay time, the lag 1 boiler will be started. Now, lag start percentage and lag start delay time are parameters that we're going to talk about a little later in the presentation, but just understand that if the demand rises to a point where you need more than 1 boiler to meet the demand, it's going to start up another boiler. Okay, so boiler number 2, or the lag 1 boiler, has been started in this case because we have a demand of 120%. The demand percentage is actually now divided between the lead and the lag 1 boiler. So we had 120% demand. It's now going to be split between boiler 1 and boiler 2. And there's different settings that determine how this is split up, but the most common situation is called parallel modulation. And this is where the demand is simply divided evenly between boilers. So we have 120% demand, which means we have a firing rate of 60% at boiler 1 and 60% at boiler 2. As the process variable changes, the PID settings are going to update the demand percentage. And that demand percentage is then divided between the boilers yet again. Okay, so in this situation, our header pressure rose, so we got very close to set point, which means our demand percentage is going to go down, and then that demand percentage is divided between the 2 boilers. Okay, so we got our rates down to 30% on each boiler. And because the demand has dropped far enough, it's dropped below the lag stop percentage for the duration of the lag stop delay, the lag boiler is actually now commanded off. Okay, so boiler number 2 has been commanded off, so you can see it there, it's gone to idle. And then we have our rate of boiler 1 has been updated to be 60% because now there's no boiler 2 to split it between. So now boiler 1 is handling all of the demand. Okay, so that's a basic sequence of operations for the master panel and how it handles changing header pressures and comparing it to the set point and then generating the demand number. So the percentage demand is a number that's going to be used throughout the presentation today to determine how you set up different settings for how basically you turn on each lag boiler. When you first walk up to a master panel, you'll often be starting from the overview screen like you see here. The overview screen gives you a ton of information about the system at a glance, basically. And I'm going to walk through each one of these numbers so you have a better understanding of what they're giving you. The first thing to look at in the top left corner here is the set point type. Like we saw on the features overview page, there's a couple of different ways for the set point to be driven. It can be a local set point, like we're seeing here, W1 set point. There's a W2 set point because we have dual set points here. You'd also have a remote set point, or maybe an outside air temperature reset set point. And this little window here is going to tell you which set point you're using. We also have our demand in the top right corner here. And so the demand number there is all the way on the right, and this is your demand percentage like we were just discussing here. So we have a 3 boiler system, we can have a total of 300% demand. So this screen right now is telling us that it's actually trying to turn on all 3 boilers at 100% firing rate because it has a 300% demand. This 100% total number here is a system capacity. So it's telling us it's trying to use 100% of the system capacity, which is equal to 300% demand. process variable is also listed here in the top left corner in red. So that just means the supply temperature for the system is 158 degrees Fahrenheit. If we had a return temperature sensor installed, it would actually be shown here in this box on the right. We have our system set point shown here on the left in green. So that's the system set point. So that's the temperature we want the loop supply temperature to be. We also have pump and valve status shown here on the screen. So if you optioned on the pump or valve control in the system setup, you would see this icon here that tells you whether or not the pump is running or it's in idle. So you can see in boiler 1 and boiler 2, the pumps are on and running, and in boiler 3, the pump is off or it's idle because the boiler is not being commanded on. The status bar below each boiler tells you what that boiler is doing. So is it running? Is it idle? Is it not communicating? Is it an alarm? It also gives you a number there, and that number is actually the LMV phase. So those of you that are very familiar with the LMVs will know that the 60 or phase 60 is normal operation, so the boiler is just on and humming along. The boiler tags are also listed below the boiler, basically just the name of each boiler. We have our lead or lag status, so we're telling you which boiler is the lead, which one's lag 1, which one's lag 2. We also have the local boiler set points for each boiler. And again, it's important to understand the distinction between the local set points and then also the system set point. And we'll get into that a little bit later on. We also have the local boiler process variable. So this is basically the temperature at the boiler. And then we have the firing rate for each boiler. If the boiler is not on, then you're not going to show a firing rate here. But if it is on, you will. So in boiler 1 and boiler 2 in this instance, we're showing a firing rate of 100% for each of them. If you have an outside air temperature sensor installed, the outside air temperature will actually display here in the bottom right corner. If you don't, it will not be shown. And then we have our system local off remote switch. It's important to remember that this is for the system. So if this is set to local, that means it's using the set points that are inside of the master panel. If it's set to remote, then it's looking for a set point from the BMS system or some other system that's sending it a signal for the set point. If it's set to off, it will command the whole system and all the boilers to be turned to off. Okay, so we click on our main menu button down here in the lower left-hand corner on our overview screen. It will take us to the main menu of the master panel. Now, when you first go here, there's not a whole lot being shown because we're not logged in. So in order to log in, we're going to click on the login button. When we do so, it'll bring up this little dialog box, and you're going to type in setup as the name and start as the password. Now, this will take us to the setup user level, which is the most advanced user level. There's also a tech user level, but typically when you're setting up a system or you're commissioning a system, you're going to do everything from the setup user level. Once you have that typed in, you'll click apply, and then you'll click close, and then you'll see that all of these other options appear on the main menu. And these are the different options that we're going to walk through in order to set the system up. The first one we're going to do is the system setup button. This is basically where you're going to start whenever you're commissioning a master panel. And this is where we're going to tell the master panel everything that it's connected to and how it's connected. Now, this screen shows all of the various options for both the hydronic and a steam master panel. So some of these options actually won't be shown together, and I'll explain which ones of those are which. But just for convenience sake, we're showing all of them on this screen. The first thing you're going to do is tell the master panel how many boilers it's connected to. You just simply put that here in the quantity section. Then we're going to tell the master panel how each boiler is connected. Now, if we go back to our example, we can see here a couple of different connection methods, right? But really it only breaks down into two different types of connections, okay? On the left side of the screen with all the blue lines, we have Ethernet connections, okay? Pretty easy to understand. We're using Ethernet cable to connect these touchscreens to the master panel. So these are going to be via Ethernet. On the right side of the screen, all the green connections are serial connections. Good way to remember that. If you need a serial COM kit, then those boilers are being connected via serial connections. The RW55 doesn't need a serial COM kit, but it is a serial connection it's using to come back to the master panel. So you're going to simply click on the connection method. It'll bring up a menu where you can select which type of method for each boiler. Simply select via serial or via Ethernet, and away you go. The next thing you're going to want to select is the lead mode. And this is how you're going to rotate the boilers, rotate the lead boiler, I'm sorry. Typically, the most common thing we see is run hours, and this is just a simple set point of how long you want each boiler to be the lead, and then it will alternate after that time has elapsed. The other two options that we have in here are LMV hours or LMV startups. In both those instances, the master panel is trying to keep the same number of run hours or same number of startups per LMV that's connected. And this is a good way to maintain the same number of run hours per boiler when you're using all LMVs. We'll talk about the differences between those two in later slides. The next thing you want to do is select the load controllers. So each boiler may have a different type of load controller. We're showing a couple of different options here. And basically, you need to tell the master panel how each boiler is being controlled and how the set points and process variables are being relayed back to the master panel. So if you have a boiler that just has an LMV5 and you're using the LMV5 internal load controller to control the pressure or temperature of the boiler, you would select what's listed here in the boiler 1 window, which is LMV5 only, okay? If you have an LMV3 system, then you have to have some kind of external load controller, which if you're connecting to the master panel should be the RWF55 because it has Modbus. Then you would select the LMV3/RWF55 because the RWF55 is acting as the load controller. There's actually also an option to use the LMV5 with an RWF55 as the external load controller. And so that's in there as well. And then there is an option in here for RWF55 only. It's not shown on this screen, but if you click through the menu here, you'll have an option for an RWF55 only for the instance that we talked about in the previous slide. The color shape / burner button here, these are the adjustable graphics that we talked about. So if you open up these buttons, it'll give you a little menu to change the color of the boiler, change the shape of the boiler, change the burner type. And that way you can make each boiler look exactly the way it is in the boiler room. System type is the next option you're going to want to take a look at. And this is very simple. It's either going to be hydronic or steam. So you're going to set it up for a hydronic system, and there are going to be different options that pop up. And if you set it for steam, there are going to be a different set of options for the steam setup. Modulation type, we talked about this briefly. Basically, there's parallel or there's sequential, okay? Parallel modulation tries to make the firing rate of each boiler the same. So basically, if you have a demand of 150%, then you're going to have, and you have 2 boilers that are on, then you're going to have each boiler firing at 75%. In a sequential operation, you basically kind of load up each boiler to 100%, and then whatever is the last boiler turn on, that's the one that modulates. So if you had a demand of 150% and you had 2 boilers running, your lead boiler would be at 100% and your lag boiler would only be at 50%. Typically speaking, parallel is the option that most people choose. We have some display options here that are pretty self-explanatory. You can change the units. You can change the system language. We have English and Spanish built into the master panel. You can change when you are automatically logged out of the system, when the screensaver pops up. If you have an LMV5 system connected, you can choose whether or not you want to display the oxygen, the O2 trim value, as either dry or wet if you have the O2 trim option on. The total capacity number that you see here, if you don't put anything in this box here, nothing will show up on the overview screen. But if you do put in the total capacity for the system, how much steam it can produce as a whole with all the boilers on, it'll put an estimate of how much steam it's producing based on the firing rates on the overview screen. The master panel can actually configure multiple touchscreen kits all at once. And these are the two options you would use to do that. You would set the auto config remote option to yes, and then you would click on the expanded enunciator setup button in order to option on things like the analog card, the RTD card, economizer monitoring, and those are all options in the local touchscreen kits. So we're not going to go into detail on this, but just know that that's an option. If you need to set up multiple touchscreens kits all at once, you can do so from the master panel. Warm standby, like we talked about before. Warm standby, you turn on this screen. You don't actually set up any of the parameters here. You're just going to enable the warm standby option from the screen. So if you want to use it, you'll turn it on here. This is a steam only parameter, which is feed water type. So if you have boilers that have an RWF55 connected to it that's handling the feed water with our level control components, then you would select RWF55 here, and that way we would gather the information from that RWF55 and bring it into the master panel so that it could then be exported to the BMS system or used in one of the other processes that we have in the master panel. If you have the system set up for hydronic, this option is shown, and this is the local boiler circulation pump and valve control. So you would turn on those controls here, and then you'd use a different screen to actually set up the parameters for that. Another steam-only parameter here is the deaerator. So if you have a DA panel connected to the master panel, in order for you to view it from the master panel, you have to turn on that option here. So you could say I have one DA panel connected or two DA panels connected, where in a case where maybe you have a deaerator and a surge tank panel, you'd select two here. If you have VFDs connected to your local boilers and you have those VFDs connected via Modbus to the local touchscreen kit, you can turn that option on here, and that way we will gather data from those VFDs back to the master panel so then it can be used in the processes inside of the master panel or exported to the BMS system. All right, so that's everything briefly here on the system setup. And we've kind of told the master panel everything that we have connected to it. Now, if we click on the email setup button here on the bottom that's highlighted in yellow, we can actually set up to 6 email addresses or phones for text messaging. So if you wanted to set up an email, you would just simply turn on the address by clicking on the button on the left, and then you would type out the email right here. If it was a phone number, like a cell phone number that you wanted to send a text message to, you actually click on the cell phone on the right here, select what cell phone carrier it is, and then enter the phone number, and then it would be entered into this bar, and you'd have it all set up, okay? Don't forget to set up your site name as well. So on the bottom here, we have a site name, and so for every time we send an email from this master panel, we'll use this site name as sort of the title. And that way you know where it's coming from. The default is lead lag master. So if you don't change this, it's just going to say lead lag master. And if you have multiple master panels sending you notifications, you may not know where it's coming from. So don't forget, make sure you change your site name when you get everything set up. Messages are automatically sent when alarms occur. So if the master panel registers an alarm, it will automatically send a message to any of the addresses that are put in here that are turned on, okay, which is super helpful for tech support people or boiler room operators when they're off-site to know what's going on in their boiler room. You can also send messages manually by either sending screenshots. You can actually send the full alarm history from a panel, and you can actually send individual emails that are custom typed out if you would like. It's very powerful, super helpful, very convenient, and very easy to set up. So we click on our main menu. It'll take us back to our system setup screen. And then from here, we're going to go into our input and output config screen. So this button down here on the bottom left, once we click on that, it's going to take us to our IO config screen. Okay. And this is where we're going to configure all of our inputs. On the screen, we actually have 4 analog inputs. So if you order a master panel that's designated for Steam, you automatically get these 4 analog inputs. You can option in the additional 4 RTD inputs if you would like to. If you have a master panel set up for hydronic, then you automatically get all these 4 RTD inputs, and you could option in the analog inputs if you wanted to. Okay, so you could get both, or you get one or the other. It's just important to remember when you get a Steam master panel, you get the analog inputs, and if you get a hydronic master panel, you get the RTD inputs automatically. We also have 2 analog outputs that you can set up. So these could be a 4 to 20 or a 0 to 10 output, and they can relay Modbus information from the master panel or other boilers. So you could send out, the firing rate of boiler number 1 on the analog output channel 1. We also have 4 digital outputs. So these are just digital outputs, contact closures, basically, excuse me. We have 4 available inside of the master panel. If we select the analog input configuration 1, it'll pull up a dialog box where you're going to set up the analog input. The first thing you need to do is name the input. And it's important to remember that names matter, okay? Because if you name the analog input header, then the system knows to follow this analog input as the process variable for a Steam system, okay? There is a table inside of the installation instructions that tells you all the various names for different process variables, okay? So if you name this one header, then the system knows, okay, that's the header pressure sensor, and I need to follow that as my process variable for the system. Once you have named the input, the other options show up, and you have to input the units for that sensor, the signal type. In this case, it's 420. And then you can also have a filter here. If the signal is a little sporadic or jumpy, you can use the filter to kind of smooth things out. Then you need to span the sensor. So in this case, we have a 0 to 150 PSI sensor. So in our min and max, we put 0 and 150. If we had, let's say, a gas flow meter connected to this input, we would be able to totalize that input. So we could say we want to totalize it via minutes or via hours in the totals box here. And then for all of the analog and RTD inputs, we can set up an alarm on this input. Okay, we can set up a low alarm and a high alarm. Okay, and there's an alarm box here on the right. This alarm box has a bunch of different options, and basically it's going to determine if you want to set up a low alarm, a high alarm, both a low and a high. If you want to set up for a low manual reset and a high auto reset, you basically just click through this until you find the option that you want. And then whatever option you choose in this alarm box, it will follow the numbers that you put in the left here. So if this alarm says none, even if you have numbers in the low and high boxes, you're still not going to have any alarm set up. You need to set the alarm value to either low or high manual reset, and then the alarms will be generated based on the numbers that are in the low and high box. So now if we go to our RTD inputs, we click on the RTD input 1 configuration, we'll get a very similar dialog box. And again, the first thing you need to do is name the input. And again, the names do matter. So in this one, it looks like we have an outside air temperature sensor hooked up. And outside air is one of those important names that we have in the table in the installation instructions. And that's going to be for the outside air temperature sensor. So it can be used in outside air reset schedules. So once it's named, you need to tell it what kind of sensor it is. So there's a little type box here. You can click through to pick the sensor type that you're using. And then there's the alarms here at the bottom. There is a little bit of an offset option here, and this allows you to compensate for very long wiring or resistance that you're getting that maybe isn't indicative of the actual temperature that you're seeing. So we have a little bit of an offset here that you can put in. And then again, we have our low and high alarms, and these act just like the analog input that we just explained. Okay, so back to our system setup screen. If we click on our main menu button, it'll take us back to our main menu. Now we're going to take a look at the set points menu. Okay, so if we click on the set points button here, we'll take a look at the set point screen. I'm showing the steam options right now. There are some additional options for hydronic systems, specifically the outside air temperature reset options. We're not going to go into those today. We'll go over those in a more advanced presentation in a different webinar. So to go over the basics here on the set point screen, we see here we have a W1 and a W2 set point. Now, these aren't just simple set points. It's actually two separate programs. And in later slides, you'll see how we adjust the programs for each one of these based on how the boiler's lead rotates and also how the lag system is set up. The W1 set point is the main set point. So if you don't do anything to the master panel, you don't close the contact, you don't use an override of any kind, you don't have a remote set point, W1 is the set point that's going to be used. There is a digital input on the master panel where if you close that digital input, you'll actually be able to switch to W2 automatically. And so then you have a W2 set point that you can use. We also have our remote set point information over here on the right. This information is read-only, and it's telling you if you have a remote set point coming in, if it's a valid set point, and if it's enabled. Okay, so in this instance, we don't have a remote set point coming in at all. That's why I chose 0 PSI. It's not valid, and there's a couple of things you need to do via Modbus in order to make it valid. And then it's also shown that it's disabled. So it's likely that the master panel is set up in the local setting, like we showed on the overview screen, and that would mean that the remote would be disabled. Local set point offset. Local set point offset is pretty nice. It basically allows you to compensate for piping losses. So if our system set point in this case is 89 PSI, but we know that in order to maintain 89 PSI in our header, we really need each boiler to run at about 10 PSI above that. We can do that right here by setting up the local set point offset to 10 PSI. And that means the local boilers will run at around 99 PSI in order for the header to maintain 89 PSI. We'll talk a little bit more about this in the next slide where we do an example. The low fire hold set point is down here on the bottom right. And again, this is the same thing as cold start or thermal shock protection. And essentially what it says is when I turn a boiler on, if the temperature of that boiler is below this set point, hold the boiler in low fire until it reaches this value. So if it's below 120 degrees, it's just going to hold that boiler at low fire and not let it modulate until it gets above 120 degrees Fahrenheit. And we do this in order to prevent any thermal shock to occur inside of the boiler and damage the boiler. We have our PID settings here at the bottom. For those of you familiar with PID, P stands for proportional, I stands for integral, and D stands for derivative. Now, I could probably spend a half an hour just talking about PID settings, but for the sake of time here, we're not going to dive into this. Just know that that's where this is at, and the PID settings control how quickly the system will react to a change in the system process variable. For more information on this, we have some YouTube videos posted about PID settings in the RW55 and the RWFs, and these PID values work exactly the same as those. Set point offset, this value is different from the local set point offset. This value actually is here in order for you to make the master panel match a gauge essentially that's in the boiler room. Sometimes gauges that are there aren't exactly correct. This set point offset allows you to kind of fudge the actual set point that's shown, or actual values that are shown in the on the master panel so they match the gauge. Mod hold delay basically just says when you turn a boiler on, I want you to hold the boiler at low fire and don't let it modulate for this period of time. So if I turn on boiler number 2, just hold it at low fire for 60 seconds and allow it to kind of even out before you let it start modulating. Pretty simple. Low fire hold high force, or LFH high force. This is probably the most complicated parameter to discuss. Basically, this is here in order to prevent the boiler from tripping out on its operating limit when it's being called to be at 100% firing rate, but it's actually going above its local set point. The best way to explain this is to use an example. So we're going to dive into an example here of a 2-boiler system. Now this is a hot water system. So our set point is at 180 degrees Fahrenheit. Got a master panel connected to our loop supply temperature sensor. And our supply temperature is 170 degrees Fahrenheit. And so the master panel is actually calling for 200% demand. So it wants both these boilers to be running at 100% firing rate in order to meet this demand. So firing rate restrictions, and we're going to talk about a couple of them here, are in place in order to prevent the boiler from reaching its operating limit. So we're going to build a little chart in the middle of the screen here, and we're going to talk about the local boiler temperature at boiler 1, okay? So the system set point is 180 degrees. So normally that would mean that the local set point is also at 180 degrees. So anywhere below this 180 degrees, we have just normal modulation. The boiler is going to be able to go to 100% firing rate all the way down to low fire, however it's being commanded to run via the master panel. But we've also set up a low fire hold set point of 120 degrees. So that means anytime the boiler is turned on and the temperature is below 120 degrees, it's going to be at low fire, okay? So the boiler's at low fire. Once it comes up to temp, then it gets into our normal modulation range, and then it can modulate normally. Now, we've also set up a local set point offset of 5 degrees, okay? So that means that we take our local set point of 180, we add the local set point offset of 5, and now we have an effective local set point of 185 degrees. That means we've kind of expanded our normal modulation range from 180 up to 185. This becomes important when we start to talk about the low fire hold high force value. Now, low fire hold high force value is set to 10 in this example. And so we take our effective local set point, which is 185, and we add 10 to it, and we get 195, okay? This means that between 185 and 195, the boiler is actually going to be scaling down from high fire to low fire, okay? And the reason we do this is maybe our operating limit is set at 210 degrees Fahrenheit. So if we left the boiler at high fire when it went above 185 degrees, it would soon get to its operating limit and then turn off. And that's not help making hot water. So even though we're scaling it back, we're trying to scale it back so it can stay on, so it can continue to supply hot water to the system, even though we're not meeting the supply set point, okay? So just to go over this one more time, if we turn the boiler on, it's below 120 degrees, it's at low fire. As soon as it gets above 120 degrees, now we're in the normal modulation zone, okay? And now this is the boiler's around 180 degrees, let's say, but just below. So it's to be able to be at 100% firing rate because it's being commanded at 100% by the master panel. But the local temperature now starts to go above 180. That's okay. As soon as the local boiler temperature goes above 185, it's actually going to start scaling the firing rate back, even though the master panel is commanding it to go to 100% firing rate because it needs more hot water to get the set point or get the supply temperature up to set point. It's going to scale back the firing rate, and it's going to go all the way down to low fire once it gets to 195 degrees. And this way, we try to prevent the boiler from overshooting the set point so far that it turns off on the operating limit. So in the example of our boiler 1 here, you'll notice that our process variable is at 196 degrees Fahrenheit. So that's right here where this red line has been placed on this chart, okay? So since we're in the low fire zone, our firing rate's at low fire. So we're assuming that these boilers are a 10-to-1 turned on boiler. So the firing rate of boiler 1 will be 10% when it's at 196 degrees Fahrenheit. For boiler 2, our process variable is 187 degrees Fahrenheit, which puts us right in here in the orange range. And so our firing rate is going to be between high fire, which was at when it was at 185 degrees, and low fire, which is what it would be at, it was at 195 degrees. Okay, so it's starting to scale back and it's down to 92%, since it's above the local set point, but still below the 195, where our low fire high force value puts it. Okay, it's a somewhat complicated topic, but again, it's in place there to make sure that we don't overshoot the local set point so badly that we actually turn off the boiler, which is not what we want in this situation. So back to our set point screen. Warm standby is an option that you can turn on in the system setup screen. And when you do so, you have all of these other options that come on in the set points menu. Now, warm standby is basically the ability to keep a boiler ready. It's like having a batter in the on-deck circle. You don't have to wait for him to warm up before he goes to bat because he's already warmed up and ready to go. So the way the master panel does that is in the system setup screen, you told it you wanted to enable warm standby, and you said, I want to enable, let's say, one boiler in warm standby. And that means the master panel is going to try and maintain one of the boilers that's off at a warm set point. The warm set point, you simply put in here. So it says, okay, if I've got boiler 1 running along and it's carrying the load, no problem. I'm going to keep boiler number 2 at 210 degrees Fahrenheit so that it's ready just in case I need it, okay? So if it goes to turn it on, it doesn't have to wait for it to warm up before it can be used to actually affect the system process variable. So you enter your warm set point right here. And then the warm hysteresis value is basically how you turn on or off that burner. So right now it's set for 10 degrees Fahrenheit. So that means when the boiler temperature is below 200 degrees Fahrenheit, it's going to turn on that burner. And if it's above 220 degrees Fahrenheit, it's going to turn off that boiler. Okay, so you basically just add this hysteresis number or subtract this hysteresis number from the set point in order to achieve your on or off points. We also have a warm minimum runtime. Essentially, this is in place to keep the warm standby boiler from turning on and off and cycling. So we basically say, even though I may overshoot my off point, let the burner run for this minimum amount of time before turning off. Typically, it's set for 10 or 15 minutes or so. We also have a standby fixed output that allows you to choose what the burner output should be when it's turned on to do the warm standby function. Okay, you can set it up for low fire, you can set it up for 50% fire as it is here. You get to pick what firing rate you want to fire the boiler at. So that takes us back to our main menu. And now we're going to go into our lead selection. So we're going to talk about how we rotate the lead boiler. In the system setup screen, if you remember, there's an option here for lead mode. And the most common one that we see is run hours. This is the simplest to understand. Run hours, basically, you're just going to rotate the lead boiler based on how many hours it's been running. So a couple of read-only items on the screen. The boilers available at the top left there. It's just telling you how many boilers are available to be the lead boiler. Below that here in the red box, you have hours remaining and minutes remaining. This is just how much time is left before there's a lead changeover. And on the right here, we have what each boiler is designated as. So right now, the lead boiler is boiler number 3, lag 1 boiler is boiler number 2, and the lag 2 boiler is boiler number 1. You'll notice that there's also an assigned lead value. This means that the master panel is actually trying to make boiler 1 the lead boiler. However, for some reason, it's not available to be the lead right now. It could be an alarm, it could be not communicating, it could be in fault for some reason. And so because it's not available, the master panel has automatically chosen a different boiler to be the lead, in this case, boiler number 3. And so boiler 3 is actually the lead, even though the assigned lead is boiler number 1. The alternation set point, this is the main parameter here. This is just going to tell you, or this is where you're going to put in how long you want each boiler to be the lead. So after 96 hours, there will be a lead changeover essentially. Lead change overlap, this is the time that both boilers will essentially be acting as a lead when there's a changeover. So if boiler number 1 is the lead boiler and boiler 2 is going to now come on as the lead in a changeover, boiler 2 will be turned on and boiler 1 and boiler 2 will both be on for 3 minutes before boiler 1 is taken offline or turned off or becomes the lag boiler, okay? Okay, so now we also have the manual alternation and the reset alternation button. Basically, if you want to manually switch to the next lead boiler, you can click the manual alternation to next lead button. However, when you do that, it's not going to reset your timers. So the values here in your hours remaining and minutes remaining will remain exactly the same when you click that button. If you then also click the reset alternation counter button, then these numbers will reset and you'll be back to 96 hours, okay? You can click them both, you can click one or the other, it's up to you. Lead skip, okay, the lead skip buttons allow you to choose which boilers are available to be the lead. So if for some reason you never wanted boiler number 3 to be the lead boiler, you can open up the lead skip menu and select that for boiler number 3, let's say. And you might do that if boiler number 3 is very old, or maybe it's a much smaller boiler of some kind. There's a couple of different reasons why you might want to make, you might want to skip a certain boiler in terms of making it the lead. Now there's a W1 and a W2, because as we discussed before, the W1 set point and the W2 set point aren't just set points, they really are different programs. So if you're running on W1, you have a different set of lead skip options. And if you're running on W2, you could set up different boilers to be skipped. In that way, you can actually have a summer and winter program essentially, where if you have W1 be your summer program, maybe you're only using 2 smaller boilers and they're only going to be the leads. And maybe in W2, you have a third boiler that's much larger, and in W2, you always want to use boiler number 3 as the lead. And you could set that up using these 2 different programs, essentially. Next, we have our lead rotation buttons. And again, we have a different one for W1 than we do for W2, because these are different programs. And that way, when you're using W2, you can have a different rotation than if you're using W1. The rotations is very simple. It's just going to be choose how you rotate the lead. Are you going to go boiler 1, then boiler 2, then boiler 3? Are you going to go boiler 1, then boiler 3, then boiler 2? And you can select how they rotate through. You can even select boiler 1 to go twice and then boiler 3 after that. So you can input that in these options. Now, if in the system setup screen, the lead mode that you selected was LMV hours or LMV startups, the options here do change. So the read-only parameters on this screen, the boilers available, again, same as it was in the last one. And also the assigned lead value is the same. The lead boiler and lag 1 boiler here are just telling you which boiler is which. But then down here, we have boiler 1 hours and boiler 2 hours. If we were doing startups, just say boiler 1 startups and boiler 2 startups. And this information is reading directly off the LMVs that are connected to the master panel. So this option is only available for boilers that have LMVs on them. And basically, this gives you a way to even out the number of hours that each LMV has been run. So you can kind of even out the number of hours that each boiler has been run, essentially. And the way this works, essentially through this hours hysteresis number. And what this says is that I want the lead to change every time a boiler gets 50 hours ahead of the others, okay? So if boiler number 2 had 200 LMV hours on it and boiler number 1 had 250 LMV hours on it, then the system would say, okay, I'm 50 hours ahead of boiler number 2. Let's do a lead changeover and make boiler number 2 the lead so that it can catch up in run hours. And the same is true if you were doing startups. It would just be the number of boiler startups you have so that they had an even amount per boiler. When you select this lead mode option, there's also this count offset button. And this is there in situations when you need to replace an LMV, or maybe the controls change, but the boiler doesn't. So what we're really after here is trying to even out the number of hours that the boilers have been run. And using this count offset button, you can actually add in fictitious hours, let's call them, to any one boiler so that the new LMV that was installed doesn't become the lead boiler all the time. So that's our lead selection. It's pretty straightforward, but a couple of really nice options there. So now we get into our lag start stop screen. And in our lag start stop screen, we're going to determine when each lag boiler gets turned on. So in our system setup screen, if we chose a modulation type of parallel, this is what the screen would look like. We're not going to go through the sequential setup right now because it's not very common. But for the parallel modulation, remember that we're going to split the demand between boiler 1 and boiler 2 evenly as much as we can. Okay, so boiler 1, 60%, boiler 2, 60%, for a total of 120% demand. So on the left here, we have our start parameters. And basically, this is just telling the master panel when we want to start turning on the lag boilers. So the numbers on the left here are the demand numbers, and the numbers on the right are the delays. So if I have a system set up with 5 boilers, I would have 4 lag boiler options here. And in the first set of boxes here, we have the parameters for the lag 1 start. And this says that when the lead boiler is running at 100% firing rate for 60 seconds, then I'm going to turn on lag 1. The second one here says that if the system has a total demand of 200% for 60 seconds, then turn on lag 2. And so in this instance, it would look like lead boiler number 1 was at 100% and lag 1 was at 100% for 60 seconds, and then the third boiler, or lag 2, would be turned on, and so on and so forth as you go down to lag 3 and lag 4. Now these percentages can be changed, and you can change this to 80%, 160%, and so on and so forth, depending on how you want to set the system up. Some systems like to be set up where you turn all the boilers on at low fire first, and then they all modulate together. In that instance, maybe you had in lag 1, you'd have 30% firing rate, and then 60% firing rate here, or 60% demand here, and that would mean that both the lead boiler and the lag 1 boiler were at 30% each for 60 seconds, and then you turn on the lag 2 or the third boiler. So totally up to you how you want to set these numbers up, but basically determining when each lag boiler is going to be turned on. On the right here, we have our stop parameters, and these work in the opposite fashion, okay? So in this instance, because we have 5 boilers in this system, on lag 4 here, we have a 350% demand for 60 seconds. What that means is the lag 4 boiler will be turned off when the demand is at 350% or less for 60 seconds. So 350% divided by 5 boilers is about 70% per boiler. So if all the boilers are running at 70% each for 60 seconds, then it will turn off lag 4 or the 5th boiler, okay? And that holds true for each one of these boilers as you go down. So we go all the way back up to lag 1. If the total demand of the system is only 50% or lower for 60 seconds, lag 1 boiler will be turned off and the lead will be the only boiler left on. And 50% split between lag 1 and lead would mean the lead boiler and the lag boiler were both running at 25% only for 60 seconds, and then we shut down the lag 1 boiler. And again, these numbers are all customizable. You can put whatever numbers you'd like in here to help set your system up the way you want them. We also have some status information here on the right. It tells us which boilers are on. So right now it's showing us that lag 1 and lag 2 are enabled, but lag 3 and 4 are not. On the bottom here, we have a max to run number. This allows us to set up a system with maybe 5 boilers, but maybe we only ever want to run 3 of them. So if we put 3 in the max to run button, right, max to run value here, the system would only ever turn on 3 total boilers. So 2 boilers would always be idle, but they would all rotate. So you'd have, you know, boilers 1, 2, 3, 4, and 5 all running through the rotation. It's just when the system's on, it's never going to use more than 3 boilers, let's say. We have some lead shutdown options here as well. You can use a timer to shut down the lead boiler. Basically, if there's no demand for a certain period of time, 5 minutes in this example, then your lead boiler actually be shut down completely. You can disable this function so the lead boiler is always on and at low fire, or you can set this up to use the process variable actually to determine when to shut down the lead boiler. A couple of different options there. All right, so moving on to some of the simpler menus here. If you wanted to view the DA, surge, or condensate tank from the master panel, and you had turned that option on in your system setup screen, there would be a button here in the middle of the screen for DA and surge tank. But this only appears if you turn it on in the system setup screen. And if you click on that button, it will take you to a screen that views the DA or surge tank panel. So in this instance, we're showing a split tank, a DA and surge tank. And this is a view only. So you're not actually able to change any of the parameters on the DA or the surge tank from here, but you can view all this information, and all the information from the DA or surge tank or condensate tank panel is available in the Modbus registers and available to the BMS. All right, so back to our main menu. Maybe you don't have a BMS, and really that's no problem if you're trying to do any kind of scheduling, because we have a full enable schedule built into the master panel. So when you click on the enable schedule, you get this wonderful screen where it allows you to set up actions based on the time of day and the day of the week. So once you enable the system, you can set it up based on a 24-hour clock to disable the system or enable the system or change set points. It's pretty self-explanatory once you get in there and just start working with it a little bit, but we're not going to go into too much detail right now. Another item we want to take a look at here is the date, time, and backup. This screen is important, and it's important for 2 reasons. One, you want to create a backup of your settings, okay? So your system settings, your email settings, once you've set everything up in the master panel, you can save your settings here, okay? You do that in a USB drive. So you plug in a USB drive either in the front of the screen or the back of the screen. And then when you click the save button on the system settings or the save button on the email settings, those settings are then saved to the USB drive under the backup file number that you've inputted there. And typically we just always use the file, the backup file name default. And it'll be saved to USB drive, and then you can use that to restore the system in the event that something gets changed and you don't know what it is. Or you can even use that to upload to a new master panel for a system that, say, you want to set up exactly the same as you had another one. The other thing that you can do here is obviously set up your date and time. And if you're going to use the enable schedule, then you want to make sure that your date and your time, your day of the week is correct so that the enable schedule follows the right timing, okay? All right, so the other thing here, we have the alarms button. So when you click on the alarms, you actually can view the system alarms and all the alarms from the various boilers that you've connected to the master panel. Okay, so you're not only getting alarms about communication to the different boilers and system alarms that we've set up on the analog inputs maybe, but you're also getting like the safety loop is open and locked out on boiler number 2 and all that alarm history. And this alarm history saved up to 250 alarms. It's all written out in clear English. It shows you when it happened and then also when it was cleared. And it's color coded, which is really, really nice. So the red alarms are LMV lockouts. The orange ones are LMV faults. Yellows are active COM faults. Green ones are actually faults that have been resolved that are communication faults. And the blue ones are all the other alarms in the system. So typically those are system alarms that are part of the master panel. Maybe they're high or low analog input alarms, or maybe they're a monitored value alarm or a circulating pump alarm of some kind. But they kind of capture all the rest of the alarms that we have in the system. You'll notice also here that we have an alarm reset button that will clear some of the alarms, and we also have alarm reset button that will clear the alarms that are present inside of the master panel. It won't actually clear alarms that are part of the LMV or part of the local touchscreen kits, but for alarms that are part of the system alarm, like the analog input alarms, then you would use this alarm reset button here to reset those. And the other thing you can do here, which is really nice, is save this alarm history to a USB drive that you plug into the master panel. And then once it's saved to the USB drive, you can obviously download it to your computer and to review, or you can actually email it out if the system has the email options enabled. All right, so we've covered a lot of the different features and functions that are in the master panel throughout this presentation. Specifically, all of these ones. But there's a number of here that we have not covered yet. Things like the BMS communications and how to set that up and how to get it communicating. The system pump controls and how to handle those. The local boiler pump controls or outside air temperature reset schedules. Data logging and trending. And even the user values like we talked about, where we can do real-time fuel to steam calculations. We haven't really had enough time to get into the details, but we have covered all the basics. We've covered how to set up your lead rotation schedule, how to set up your lag boiler setups, how to set up the system in general, and how to tell the master panel what it's talking to. So I hope we found a lot of value in the items that we have covered here, and look out for another webinar where we dive into the more advanced features on the master panel. And if you have any questions about those things, feel free to reach out to your SCC National Account Manager, and they will be happy to walk through any of these items with you. So that concludes the presentation portion of our webinar. And with the time remaining, we'd like to answer some of the great questions that we've been fielding during the presentation.
Thanks, Dan, and thanks to everybody for attending the webinar. After the virus travel restrictions are lifted, we will continue our formal training classes in Chicago and look forward to seeing those of you with additional interest in hands-on training of all of our products and systems. Please contact your local rep or account manager to schedule. So with that being said, we'll jump right into the question and answer period with what we have remaining. A lot of good questions. We won't be able to get to all of them, but we will get back to you for sure. So I'm going to start with the first one here, Dan. Speaking about a steam boiler application where we have an existing LMV3 or an LMV51, and we have no touch screens at the burner itself or a PLC. Can I monitor the boiler's stack temperature from the master panel and generate an alarm output?
Yeah, great question. The answer is yes. If you add the optional 4 RTD inputs. The master panels for steam boilers come standard with 4 analog inputs, but you can add the 4 RTD inputs as an option. You can then install standard PT1000 RTDs in the stacks of up to 4 different boilers and then wire them back to the master panel. Then, using the RTD configuration screen like we showed earlier in the presentation, you can set up a manual or auto reset high alarm on each one of these inputs. These alarms could be then sent to the BMS, and they would be also logged in the alarm history. Once the inputs and the alarms have set up, you have 2 relay options to choose from. The master panel actually has a common analog input high alarm relay, which will be energized anytime any of the analog inputs set off a high alarm. So you could hardwire that one relay to an alarm relay or a BMS digital input. The other option you have is to actually use the 4 digital outputs that we showed in the input-output config screen. And you could assign 1 digital output to each RTD, creating a dedicated high stack temperature alarm or dedicated interlock function. And this would give you the ability to do basically a high stack temperature shutdown. Yeah, great question. I got another good one here for you, Alan. What would happen to the steam plant or hot water plant in the case where the master panel is hit by lightning or water, or is for some reason fails due to a loss of power?
Okay. Again, a good question. I'd love to be able to say that our panels can handle 100 million volts of electricity, but unfortunately, that's not the case. So So fortunately, all the Siemens LMB series controls and all of our RWF55 controls have a dedicated watchdog timer. All of our products are slave devices when it comes to Modbus communication. So this timer specifies the amount of time allowed with no Modbus communication from the master panel until the LMV or RWF controllers revert back to local pressure temperature control based on a local set point. This is very important, especially in a hospital setting where you don't want to lose your ability to run your boilers. It makes for a great specification for reps out there that are looking at specifying this product, so you don't lose your steam plant or your hot water plant. In the case of a hot water boiler where the master panel is controlling the primary pumps or the isolation valve at the boiler, the associated relay contacts that are actually located in the master panel will fail closed so that the pump or isolation valve will run or remain open. This also ensures that the master panel doesn't affect the ability to operate hot water boilers locally. So good question for sure. Let's see if we can grab a few more of these. All right, here's a question we get get asked quite often is, can the master panel itself control a deaerator and or a surge tank?
Yeah, and the short answer to that is no. The master panel has the ability to monitor a number of analog inputs from the deaerator to the surge tank using either the analog or the RTD inputs, or even some of the digital inputs. But you need a separate DA or surge tank control panel in order to actually control the pumps and lead lag the pumps on the DA panel. I'm sorry, on the DA tank. You could use the SCC Inc. DA surge tank panel to do that, and then using an Ethernet connection between that panel and the master panel, you'd be able to view and monitor all the information on that DA panel and then communicate it back to the BAS. Good question. Here's another one I found that's good. I do not have a building automation system, but I want to be able to view the master panel information on my control room PC. Alan, is that possible?
Yes, I think you mentioned it briefly at the beginning of the presentation, some of the capabilities, but yes, SCC has developed the ACS 800 software, and it is available to load on a PC or laptop. It can be directly connected to the master panel via either a Cat5 cable, or the master panel can be connected to your internet or intranet and accessed from any PC laptop on the system that has the software installed. In addition to monitoring, there's a password protected access that allows some ability to make non-safety related changes to the master panel settings, as if you were right in front of the master panel. System set point, for instance. You can also data log up to 8 variables. Any variable that's on the system or in the master panel that has a Modbus address or an address period, you can actually do data logging on your PC laptop, and it is exported as a .xlsx file, and you can use that in a spreadsheet program like Excel, for instance. One thing to remember if you're going to load the ACS 800 software is you do need a 64-bit version of Windows 7 or newer as a requirement for your PC. So good question, and it's a great little software package that we offer folks. Eventually we'll have that available on our website as well. Good question. All right, so let's grab a couple more in here if we can. Okay, Dan, SCC local touchscreen products can be purchased as kits without an enclosure to be mounted in an existing enclosure. So in other words, you can buy the touchscreens and first out enunciators to be on a kit or a back pan without a panel. Can the master panel be purchased as a kit without a panel?
Yeah, thanks, Alan. No, the master panel comes only as a complete UL listed panel. The majority of master panel applications are new installations or they're replacing installations of existing lead lag panels, and they're going to be mounted, separately on the wall. And as a result, the only option for the master panels are complete enclosures. We have NEMA 1, NEMA 4X, or NEMA 12 as an option, and you can actually add cooling fans to any of those options as well. The local burner boiler touchscreen kits are designed so that retrofits of existing panels can be conducted without the requirement to replace the panel altogether. It's also for burner boiler OEMs that build their own unique panels, and allows them for like ease of installation. They can take the back pan and the touchscreen and just mount it into their existing panel. So the touchscreen kits, yes, you can buy as a back pan with a touchscreen, but the master panels we only offer in an already built enclosure that would then be mounted in the boiler room. Yeah, good question. We do get that question quite a bit. Okay, cool. Scrolling through the rest of these here, it looks like we got time for about one more question here. So Alan, I'm gonna send this one to you. Will the master panel communicate with non-Siemens controls like Honeywell or Allen Bradley?
Okay, again, a very common question. I'm not surprised to get it was asked again, but the answer to that is basically no. Big picture, the master panel, our local touchscreens and PLCs are digital communication devices, and there's a lot more programming than you realize that goes into making these products. So for applications with third-party controls that require lead lag, auto rotation, hot standby, low temperature, low fire hold, the minimum requirement that we need at each burner boiler is an RWF55. Now the RWF55 will provide the Modbus communications back to the master panel, and it will also allow for both a pressure and temperature sensor to be wired to the RWF55. That information can then be viewed at the master panel, and hot standby and low temperature, low fire hold functions can be activated. Just remember also, for a single point jack shaft burner where you're still using a mod motor that has, say, 135 ohm modulating input signal, that motor will need to be modified or upgraded to allow for a 4 to 20 milliamp or a 0 to 10 volt modulating signal. Now those types of drawings on how to do that are available in our technical instructions, and our SCC tech support group can also provide assistance if you have any questions. So again, a good question.
Oh, thanks, Alan. It looks like that's about all the time we have today. A lot of really great questions that you guys sent in. Thanks a lot for all the questions. If we didn't have a chance to get to your question, don't worry, we have it recorded, and your SCC account manager will get back to you with the specific answer that you're looking for. Your SCC account manager will also be happy to go into more detail on any of our Total Boiler Room Solutions products, and they would be also very happy to discuss any specific applications or technical questions you might have, so feel free to reach out to them. If you don't know who to contact, feel free to reach out to our marketing email address, and we'll get you pointed in the right direction. These panels can do a ton of stuff, and we really are only scratching the surface on the master panel today. So if you have a unique situation, you're thinking, I don't know if it could do this, please ask. Typically speaking, we can find a way to make it work using the functionality that we have built into the master panel and the local touchscreens and our DA panels and the various other control devices that we have available here at SCC Inc. If you missed our Total Boiler Room Solutions 101 class, please let us know. We're happy to send you a link to the video. It is recorded and it's available to be viewed online. Please also look out for an invitation coming up for our next webinar in this series, the Total Boiler Room Solutions 103, where we actually will be covering the features and functions of the touchscreen kits and combustion enclosures. And those are the touchscreens and panels that go on the boiler themselves. Okay. That concludes our Total Boiler Room Solutions 102 webinar. Thank you, Alan, for being our moderator, and a big thank you to everyone who joined us. And as always, stay safe and have a great day. Thanks.
Take care, guys.